the example that I had up on the board yesterday, right at the end. Yeah, and then I have one more example just to make things more interesting. Okay? So we started with this one. No, this one. 1 plus sine of x equals 2 cos squared of x. Now, if I recall correct, we had already done the sine squared of x plus cos squared of x equals 1, and we solved this for cos squared. So subtracting, we get cos squared of x is equal to 1 minus sine squared of x.
I mean,
Right?
you could do it that way, but that's not the way to do it.
Well, we actually put all that over first, and then we did this.
We never got to that point.
Oh, we didn't?
Do you want to see what I have?
Yeah, we did. I have that as a side note.
So what we did, you said, well, let's get everything on this side. So what we did is we said 2 cos squared x minus sine of x minus 1, and we said that that was equal to 0, I believe. Right? Then we did this,
And then we subbed in.
and then we subbed that in. Okay?
Okay, I'm sorry.
It's okay. No, you're groovy. It's all cool. I did do it in a little bit different order, so.
Oh, I have that as a side note. I'm so sorry.
It's okay. Don't worry. Be happy. Okay. Okay. All right. So if we distribute the 2, all right. So one of the reasons we moved everything over to that side was to make everything, the leading coefficient positive, right? But now what? The leading coefficient is negative. So we can move it all back over here, or we can divide by -1. Okay, and let's get it all in descending order. Okay, so what I'm doing, it's like moving it all to the other side. It's basically like moving it all to the other side, but I'm going to keep it on this side because we can write it on either side. Yes, dear?
On the one, like that one right there, is it supposed to be 2 cosine squared of x?
No, no, no. This is a Pythagorean identity. This is the Pythagorean identity. The Pythagorean identity says sine squared plus cos squared is equal to 1. Okay? And so we're going to use that identity to replace cos squared with a like function. Because this one is sine, we need the functions to match. Those don't match. They're not matchers, and so we have to get them to match.
I see what you're saying.
Okay? All right. So this is going to be positive 2 sine squared of x. That becomes positive. Then plus sine of x. That one becomes positive. Now 2 subtract 1 is 1, so this would be -1. Okay, now just making sure, I see question marks on faces. So it's like moving it over here. So if I move this over to this side, it becomes 2 sine squared of x. If I move this over to this side, it's sine of x. And if I go 2 plus a -1, I get +1, and I move it over to the other side. So I kind of did 2 steps at once.
Or you like divided by 9.
Or it's the same thing as dividing by -1. Both sides of the equation. Ruby? Shayla, you have this big question mark right on your, it's going like this.
I just don't get when you distribute it, you changed it from cosine to sine.
So, since these are not the same function, they're not the same base function, I said, ooh, the only way I can factor those is if it is the same. So I came over here, this is side note, sine squared plus cos squared equals 1. So I solved this for cos squared. So cos squared is equal to 1 minus sine squared of x.
Okay.
So I replace cos squared of x with 1 minus sine squared of x by the Pythagorean identity. Okay, is everybody caught up now? Okay. So now, see if you guys can factor this one. Okay? I'm going to let you try to factor it. We did one yesterday where you factored it. It was a harder factoring than this one. Done something like this, 2a squared plus a minus 1, and factored that. That was a helpful thing for you yesterday. Some of you might want to go back to that.